Hello, my mathematicians. Today we are looking at Module 6, Lesson 3, which is about representing subtraction with different sized parts. Hopefully by the end of this lesson, you'll be able to represent the difference between fractions with different sized parts using a visual model. So we are going to start with the spark you're learning. It says, Mark and his friends are putting on a play. Mark is in charge of the costumes. He measures each sleeve in one costume to be 3/4 yard long. Each sleeve should be 1/2 yard long. How much should each sleeve be shortened? So we're going to draw a visual model to represent how much each sleeve should be shortened. So if we are going to start with a model here, and we're going to split it into force. I'm going to shade it in. So 1, 2, 3. So this is my 3/4. And then we're subtracting, so we're going to put underneath, we have a hole. We're going to split it in half. And I'm going to shade that half in. So if we look at this, we can see the difference here. If we just cut off the half there, this is our difference. And this is 1/4 of a yard. So we would have 3/4 minus 1/2 equals 1/4. So how much should each sleeve be shortened? Well, it should be shortened 1/4 yard. We're going to go on to the next page. So this is Anderson and Joanne sold tickets for the play. Anderson sold 3/4 of the roll of tickets, and Joanne sold 1/6 of the roll of tickets. What is the difference between the fractions of the roll of tickets that Anderson and Joanne sold? Explain what the dashed box in the fraction model represents. Well, this right here is going to be the difference. So it represents the difference 3/4 minus 1/6. And then it asks, who sold more tickets? And how do you know? Well, if we scroll back up here, Anderson was the 3/4 and Joanne was the 1/6. If we look at our picture, 3/4 takes up more room, so it's going to be Anderson. We know this because 3/1/4 fraction strips represent a greater amount than 1/1/6 fraction strip. So next it says, use the fraction model in part A to draw fraction strips in the dash box to solve the problem. What size fraction strips did you draw? Well, if we think about the multiples of 4 and 6, we have for 4, we have 4, 8, 12, 16. And for 6, we have 6, 12, 18, 24. So they both share 12. And the 4 here has it as third multiple. So that means we can split each fourth into thirds. And they're all then going to be 1/12. So we have 1/12 fraction strips. They are the only ones that fit because 12 is a multiple of both 4 and 6. I have a 1/12 on all these spots. So then it says, what is the difference between the fractions of the roll of tickets that Anderson and Joanne sold? Well, we have 1, 2, 3, 4, 5, 6, 7 twelfths. So 7/12 of the roll of tickets. So next it says 2 boxes have the same number of play programs on the first night of the play. Diana handed out 2/3 of a box. On the second night, she handed out 5/12 of the other box. On which night did Diana hand out more programs? How much more of a fractional part of the box did she hand out? So it says draw a visual model to represent the situation. So we're going to do day 1, she had 2/3. So we're going to set up 2/3. Day 2, she had 5/12. So put 5/12. So this shows our visual here. So then it says, on which night did she hand out more programs and how do you know? Well, if this is day 1 and this is day 2, she's going to hand out more on the first night. Because the visual model shows 2/3 is larger than 5/12. So how much more of a fractional part of the box did she hand out? Well, if we look here, if we're trying to figure out this section, we already know if we split this down the middle here, that 4/12 fit into 1/3. So that means we could put 3 more 12ths there, which would be 3/12 more. So we're gonna have 3/12. And how does our visual model show this? Well, our visual model shows that 4 1/12 fit under 1/3, and so we need 3 more to complete the model. This is our lesson for today. Hopefully you are now able to represent the difference between fractions with different sized parts using a visual model. And remember, in order to be a math person, all you need to do is be a person and do math.